Hi, you guys. How's everybody doing? Are you sick of being home yet? Or are you doing okay? So this is going to be interesting. Please communicate with me as much as you can. I would love to hear from you. I miss you already. We are, well, it's all on Canvas, but just make sure you're getting through everything. Correcting the homework, watching the video. If you have questions, tell me what questions you have. I will try and upload videos of me going over questions. Yeah, do the homework and then make sure you turn the homework in. I would just turn it in that same day, but it's technically due the next day by 8 a.m. So that way it gives me time to hopefully answer some of those questions through the day. So, all right, let's do this. We are starting with 9-4A today, which is Arithmetic Series, not sequences anymore. And I'm sorry if I mix up my words on those because they're so similar. But this is different than a sequence. This is a series. First thing you need to know is with a series is the sum. Sum, remember, is adding. By the way, pause me. Like if I'm going too fast, you can pause me. You can rewind. You can hear things again. You do not have to move at my pace. I'm going to try and move fairly quickly so that people can keep up, or people can keep moving if they want to keep moving. But pause me if I go too fast. Sorry, I had to pause. I don't know what I said last, but we are doing a series, which is the sum. Oh, Siri thinks I'm talking to her. The sum of the terms of a sequence. Okay, so we've talked about sequences. We've talked about series. We're going to start with sequence so that I can show you how a series is different. So with a sequence, remember, well, we'll just go down below here. A sequence would be like 6, 9, 12, 15, 18. Notice there's no ... at the end of this. We call this a finite. In other words, it does not keep going. It stops. Okay. The way we know that is there is no ... on this one, right? So it's finite. It has a stopping point. And this is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 terms in this finite series. Okay? Whereas if I do something like this, if I give you 3, 7, 11, 15, ... this is an infinite series. So there's finite and there's infinite. Infinite keeps going forever. Okay. And the number of terms in an infinite series is infinity. That's the infinity symbol, right? As like a sideways 8, infinity. Okay, so that's sequences. There's finite, there's infinite. But then we also have, what we're going to talk about more today, are series. Okay, and with series, now we're adding them. So it's the sum, remember? We're saying 6 plus 9 plus 12 plus 15 plus 18, okay? No ... This is a finite series. And the way we talk about it, it's a sum, so S being sum, okay, that means sum, S sub 5, because there are 5 terms, and the sum of them, if you add them all up, 6 plus 9 plus 12 plus 15 plus 18, you could just plug it into your calculator. But the sum here is 60, okay? Whereas if I were to do it with the infinite series, 3 plus 7 plus 11 plus 15, and then it's dot, 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 right? This is infinite. It keeps going. The way we write this is the sum is infinity because it just keeps going. Okay, so those are series. Okay, so there is a mathematician. His last name is Gauss. Sorry, turn my phone on. And his teacher back in the day said, find the sum of the first 100 numbers, as I think he was 10. 1 plus 2 plus 3 plus 4, right? A 10-year-old having to figure this out all the way up to 100. And Gauss is a genius. And so rather than sit there and just add all these numbers up, he came up with this idea that what if I wrote them backwards? So 100 plus 99 plus 98 plus 97 all the way down to 1. Well, if you look at this, if we think vertically here, if we were to add these together, these all come out to 101. Right? All the way down, 101. So what he figured is, okay, well, there's 100 of those, so we should multiply 101 times 100. So 100 times 101, but then we used each one of them twice, right? Once on the top and once on the bottom, so we have to cut that in half. So what we get is 5,050. Okay, so Gauss came up with that. Can you hear my baby crying? She's sick. No fun. Hopefully she goes back to sleep. Okay, so what that is then is he came up with a formula without even realizing that he came up with a formula here. And the formula is this. It's how you find the sum of a finite arithmetic sequence. Okay. Excuse me. So here's the formula. S sub n equals, and now if we think about what he did here, we took the number of terms, his was 100, and cut it in half, and then multiplied by the first term plus the last term, right? 1 plus 100, 101. So just keep in mind when you're doing this, whenever you see n, it's the number of terms. Whenever you see a sub 1, just like it's always been, that is our first term. And whenever you see a sub n, that's going to be the last term in this setup. Okay, so you're going to use this formula a bunch today. Let's do some. Example 1. So we're going to say find the sum of the first 100 numbers. We're going to do Gauss's problem that he had to do as a kid. So we would say if we're taking this formula, the sum of the first 100 numbers is going to be your n, which is your number of terms, so there are 100 of them, divided by 2. And then the first term, if we're thinking 100 numbers, first term would be 1. Last term, a sub n, would be 100. So you plug that in, and you can plug that into your calculator exactly how you see it there, or you can simplify 50 times 101, that's fine too. But that comes out to 5,050. Okay, so that's the sum of the first 500 numbers. Example 2. We're going to say find the sum again. Okay, find the sum of 5 plus 6 plus 7 plus 8 plus 9 plus 10 plus 11. Okay, and you could just plug that into your calculator. I'm just showing you with a small set of numbers because you can do the same thing with a bigger set of numbers then. So for this one, we're saying the sum of, there are 7 numbers, 1, 2, 3, 4, 5, 6, 7, okay, is n, which is 7, divided by 2, always divided by 2, right? I'm just plugging back into this formula, times my first term, which is 5, this goes here, plus my last term, which is 11. And again, you can just plug that in. The sum of those 7 numbers would be 3.5 times 16, or just plug it in as you see it. And that would be 56. Okay. Okay, so those ones are fairly simple. Here's where they get a little bit fancier. Example 3. Let's say we have 500, 490, 480. Oh, I'm doing commas. These are pluses. Sorry. Sequence. I'm doing sequence. This is a series. Plus 10 at the end. Okay. So if this is my setup, first of all, this is an arithmetic sequence. If you look at what's happening, right, each one of these, we're subtracting 10. So my common difference is a negative 10, right? So if we were going to set up this equation, the sum of some number of terms is going to equal n over 2 times my first term plus my last term, right? First term and last term. So we have this, but we don't know what n is. We don't know how many terms we have here because there's all this missing in the middle, okay? But in order to find n, okay, so if we're going to find n, we are going to do an explicit formula for this setup. Okay, and it will be an explicit formula every time. You won't do a recursive for this. So if we set up the explicit formula, remember how the explicit formula goes. You have a sub n equals your first term, so the 500, plus, and now you can write this either way. Remember, it was the way I initially showed you this is this. A sub n equals a sub 1 plus n minus 1 times d, okay? I'm just going to put the d out in front here because I feel like that's how people tend to think mathematically more. So this would be 500. My common difference, we said, was negative 10, so minus 10 times n minus 1. So if we simplify this, we get a sub n equals 500 minus 10n plus 10. So a sub n equals 510 minus 10n, or you could say negative 10n plus 510. Okay. Now here's the thing. Remember what a sub n was? A sub n was our last term. Well, if you look up here, we know our last term. Our last term is 10. So what we're going to do is we're going to plug that 10 in and solve. Okay, so take away the 510, take away the 510. So we get negative 500 equals negative 10n. And then we're going to divide by negative 10. So I get n equals 50. Okay, so if n is 50, and I'm trying to figure out the sum, I'm going to go back to my sum formula that I found at the beginning, and I'm going to plug my n into it. So it's going to be the sum of the first 50 numbers here, or sum of the 50 numbers in our series, is 50 over 2 times 500 plus 10, or you can just say 510 right there. Maybe that's not as clear what I'm plugging into. 500 plus 10, right? And then if you want to simplify from there, you can simplify, or you can just plug it into your calculator. So the sum of the 50 terms is 12,750. Okay. All right, next one. We've got two more. So this is example 4, same type of problem. Let's say we have this series, -5 plus 2 plus 9 plus 16 plus something, a whole lot of somethings, plus 268. Okay, so this is our setup. We are going to set up the formula. Remember, the formula is this. We'll just write it here so that we're clear. N divided by 2 times a sub 1 plus a sub n. Okay, so looking at this formula, a sub 1 is here, a sub n, that's your last term here. So it's going to be n over 2 times -5 plus 268. Okay, remember from here, we're going to write the explicit formula. So I'm going to do it over here so we don't run out of space. All right, so our explicit formula for this is a sub n equals your first term, so this -5 is coming over here, plus the common difference. Remember, your common difference is what are we changing by? These are all plus 7 plus 7. So 7 is going to be my common difference times, and then it's always n minus 1. So if we simplify that, a sub n equals -5 plus 7n minus 7. Simplify again, a sub n equals -5 minus 7 is -12 plus 7n. And then from here, I feel like this is where people maybe forget the step. You know this number, right? What number is that? Think about that. In this series, what number is that? It's this number, right? It's the 268. So it's going to be 268 equals -12 plus 7n, and then we solve. Add 12. So I get 280 equals 7n, and then I divide by 7, and n is 40. Okay, so now we have our n. We're trying to figure out the sum, so I'm going to take that n, lots of arrows, huh? And I'm going to move that over here. So the sum of the 40 numbers in this series is 40 divided by 2 times -5 plus 268. So our sum of the 40 numbers, if you plug that in, you get 5,260. Okay, and just make sure you show your work on this stuff. There's a lot going on here, and I'm not going to necessarily be there when you're being quizzed or tested on things. More info to follow on that, because we still don't know exactly how we're going to do that, but we'll figure it out. All right, last one. Example 5. Let's say there are 30 rows of seats in some big hall, okay? Some big concert stadium or something. The first row has 10 seats, and then each row increases by 5 seats. Okay. So 2 questions for you. First question is, how many seats, it's an A, in the last row? It's my dishwasher, sorry. Second question is, what is the total number of seats in the stadium? Okay, so what I would do is I would set up a series to think through what this is. So our first row, we know our first term, right? First row has 10 seats, so we know we're starting at 10. Okay, so let's just set up a series here. Starting at 10, and it says each row increases by 5 seats. So the next row has how many seats? Man, I wish you were here with me. It's so much more fun to teach a lesson to people that are talking back to you. So 10 plus 15, 5 more seats would be 20. 5 more seats would be 25, and so on and so forth. Here's the trouble, though. We don't know how many seats are in the last row, but what do we know? If you look up here, there are 30 rows in the hall. So we know the number of terms, right? That's our n, is going to be 30. We just don't know what that 30th term is. So if we take this, now we can make our explicit formula, and we're just going to be solving for something different this time. So our explicit formula would be a sub n equals the first term plus the common difference, right? Each one of these is plus 5, plus 5, plus 5, so that's our common difference, times n minus 1, okay? And we said n is 30, right? Our number of terms is 30. So if we plug that in, 10 plus 5 times 30 minus 1, or 10 plus 5 times 29, if we keep simplifying, or you could just plug that into your calculator how you see it, right? We would get 155 for our a sub n. Now remember what a sub n is. Whenever you see a sub n, that is your last term. Okay, so when it says how many seats in the last row, this is our last row. So we would say there's 155 seats in the last row. Okay, that's our part A, our first question. And then part B is, what's the total number of seats? Well, now we're looking for a sum, right? So we're going to plug it into the sum formula. The sum of those seats is going to be the number of rows divided by 2 times our first term, 10, right? The first row has 10 seats, plus our last term, which is up here, which is really right here, 155. So that would be our setup. And again, plug that into your calculator. You get the sum of the 30 rows. How many seats total? 2,475 seats. Okay, and that is it. Happy homeworking.